What exercises did you try? What did you not understand? What would you like me to think about?
Do you have a test question paper handy? Because I can't find mine.
The mock?
No, the actual test.
Okay, yeah, I do actually.
I can't remember what the question.
I will be going through the actual test properly
Okay.
tomorrow, but
Okay.
I can ask something quick. You've
can
got a
I-
burning curiosity.
Well, trying to remember the question. Okay. Did better than I thought of that.
Can I ask how many of you got over 70? All of you. So the only people who turn out the glasses are the ones who don't really need them.
Well, you can always improve.
You can always improve, it's true.
Can you go through 12?
Quickly. Oh yeah. Okay, so I'm not going to write many workings as you should when you're answering these things. I'm just going to do it quickly. Okay, so pi 1 is going to be q1 over root q1 plus q2. So their quantity times the price. What do they have? And then minus q1 pi 2 is going to be q1 over root q1 plus q2 minus 2q2. Okay, so the first order condition for firm 1. The easiest way to think about this is q1 times this to the power of minus a half. Okay, so just using the normal product rule. Okay, so you get derivative of the first thing times the second thing. So 1 over root q1 plus q2. So that's the derivative of this times everything else, and then the derivative of something to the minus a half is minus a half times the thing to the minus 3 over 2. Okay, so minus a half q1 plus q2 to the minus 3 over 2 all times q1. Okay, and then we get a minus 1 there. So putting it to the other side, we get equals 1. Okay, so that's the first order condition for firm 1. Same thing for firm 2. 2 minus half. Same thing you always do, add the two first order conditions together. Okay. So you're going to get 2 over root q, and I'm just writing q as the sum of q1 and q2. When you add these together, q1 plus q2 gives you a q, and you've got a q inside. Okay, so you've got minus a half q to minus 3 over 2 all times q. Well, this is going to be equal to 3. So q times q to minus 3 over 2 is just 1 over root q. Okay, so 2 over root q minus half 1 over root q. I hope I haven't made a mistake. It's 3. Okay, so you want to solve this to get root q. Okay, wait, just a second, I'm having a sleep. Pretty sure. Stupid in some way. No. That's fine. Sorry. Okay. So is this what I had there? So let's put this as a common fraction. I don't know why I'm slow. Okay. So this is 2 minus a half over root q. So times both sides by root q. Okay, you get 3/4 is 3 root q. Okay, so root q is 1/4. Okay, so q is 1/2. No, that's not right. Good, but I can't see the problems. I can't see where I've been stupid.
Shouldn't it be 1.5?
Yeah, instead of 3/4,
Oh.
2 minus a half.
Yeah. Sorry, I've been very busy the last few days. I'm not really with that. Okay, so 2 minus a half is 4 over 3 over 2. Okay, so 3 over 2 is 3 root q. Thank you for saving me there. Okay, so root q is a half, so q is a 1/4. Okay, so that's right. Took me a bit longer than it should have done. Q is a 1/4. Which one do we want to find? The one with the higher marginal cost. Okay, so then you just substitute it into this first order condition. Okay, so root a quarter is a half. Okay, so this is 1 over a half. So 2 minus half times. Okay, this is a 1/4 again. So 2 times 1/4 to the power minus 3 over 2 times q2 is equal to 2. Root a 1/4 is a half. A half to the power of 3 is
An eighth.
yeah, 248. Yeah, so this is 1 over an eighth. So this is 8. Okay, so this is 2 minus half times 8 q2 is equal to 2. 8 over 2 is 4. So, and let's get rid of the 2's. Okay, so that you don't really need those. So minus 4 q2 is equal to 0. q2 is equal to 0. So it's a slightly, it's an interesting case because in fact the other firm isn't producing anything. And if you increase their marginal costs even more, so if their marginal cost was 3, how would you solve this problem? Hey, come on.
Sorry,
Don't worry. So what would the solution be like if their marginal cost was 3? Even, you know, don't need to do any calculations, you just guess.
Still be 0, wouldn't it? The marginal cost goes up further.
Yeah, so they still produce nothing. But now, if you just solve the problem this way, you'd get something funny if you solve a problem this way, you get something negative, okay? It ought to be 0, but you get something negative if you solved it this way. So, in fact, what the solution would be in that case is just the standard monopoly solution. So you solve a problem, you get something negative, and you think, oh, something's gone wrong. That doesn't make any sense. It must be the standard monopoly solution. Okay, so the trick with these things, I'm sorry I was so slow. First order conditions, that's easy, add them together. It's always what you do with Corno. It's always the easiest way of solving. If you start, finding Q1 from this expression and substituting in, it's going to be horrible. If you just add them together, you get something quite neat quite quickly. Okay, so let me see what exercises were in the lecture. So we had a price discrimination lecture. Did you ever go at any of these? I suppose with a test you probably didn't.
Were these the ones before the test?
Yeah, either before the test or after the test. So from 5.7 we had some ones on price discrimination. Okay, the first one's not very interesting. I say question 6 is tricky, so shall I go through that one? Oh, that's a durable good one, so maybe it's more good. Yeah, those aren't so interesting. You didn't have a go at any of those, I suppose. Well, if in a future week you have a go at them and you have problems, let me know. 13.5, question 1. That's very easy. So I think there are some exercises in my slides as well. Okay, so let's have a go at this. Have you got your lecture notes in front of you? This linear demand thing. I can put it on the projector if you want.
Which lecture?
The lecture 5, price discrimination, slide 24. Linear demand example 2 of 2. Is that something tricky? Going through.
Which one was it you said?
Yeah, that one. Okay, everyone can see one. So I'll write what the problem was on the board. We had there were 2 markets, each with a different demand curve. In the first demand market, the demand curve was 1 minus P1. In the second market, the demand curve was A minus P2. Okay, and if you could discriminate, it's pretty easy to see that the optimal price, if you can discriminate in the 2 markets, is P1 is a half. This is what I did on the first slide, and P2 is A over 2. Okay, so the total quantities are going to be a half and a half A over 2. So the total output is going to be 1 plus A over 2. That was the first slide. And then, So this is with discrimination. They can set a different price in both markets. So then we want to look at the case with discrimination and find out if it was better or worse. Okay, so so we said if they decided to sell in both markets, then the total demand they face is this thing plus that thing. Okay, so total demand in that case is 1 plus A minus P1 minus P2. Oh, there's only one price in there. Sorry, 1 plus A minus 2P. Okay, they have to set the same price in both markets. Okay, so they get 1 minus P from the first market, A minus P from the second. So total demand of 1 plus A minus 2P. And you know, it's a simple monopoly problem to solve for the optimal price. And this is going to be at P is 1 plus A over 4, okay, which means total quantity is 1 plus A over 2. So that's one thing they can do. They can sell the good to both these high value consumers and the low value consumers, and they also have the option of just selling the good to the high value consumers. Okay, so they can price the other type out of the market, if you like. They sell to just these consumers, just as here they're going to set a price of a half. Okay, so in the alternative scenario, they set P as a half, and total quantity sold will be a half. Again, the exercise was show the firm will sell in both markets when discrimination is not possible if A is bigger or equal to root 2 minus 1. Okay, so assume discrimination isn't possible, we're in this world. Does the firm prefer this option or that option? So how would you go about solving that? So if you like, you know, one way of thinking about this is strictly the demand curves will max 0 come with these things. Okay, so in this sum of the two demand curves, there's going to be a kink. Okay, so the choice could be at one of these kinks. Okay, so there's what's it going to look like? Like that with a kink. Okay, so there could be a solution there. So how are you going to decide between these two options?
Work out profits.
Yeah, exactly. You're just going to work out profits in both cases. It's not actually so difficult. Okay, so profits, marginal cost is 0 here. So profits are just price times quantity. Okay, so in this case, the top case, profits is going to be 1 plus A squared over 8. In this case, profits are going to be a quarter. Okay. So all we have to do is see when this thing is bigger than that thing. So it's not actually so difficult. Okay, so well, this thing is going to be bigger than that thing if 1 plus A squared, so let me write it down. So let's call this pi 2 for selling in 2 markets, and let's call this pi 1 for selling in 1 market. Okay, so pi 2, what are we interested in? Selling both markets. Okay, so pi 2 is bigger or equal to pi 1 when 1 plus A all squared is bigger or equal to 2. Okay, so taking the square root of both sides, 1 plus A is bigger or equal to root 2. If you think about what the graph of a quadratic looks like, we're interested in all the points bigger or equal to 2. Okay, so in fact, we're going to be two areas that will satisfy this. Okay, so there could be A really big and A really small, but A is certainly positive here. Okay, so we don't kind of don't have to worry about that one. Okay, so A has to be bigger or equal to root 2 minus 1. So what's the intuition for this? Well, if A is large, then the demand of this second type is quite close to the demand of the first type, so it makes sense that you want to sell to both of them. But if A is really small, then selling to this second type doesn't really get you very much. Okay, in order to persuade them to buy something, you have to bring your price down a lot. You have to bring your price down below A. But when you do that, you lose revenue that you would gain from selling to the first type. Okay, so without discrimination, you sometimes want to just cut the low value types out of the market. And if you solve for welfare in this model, you'd find that welfare was basically just an increasing function of output. Okay, so welfare would have improved by allowing price discrimination just if you're in this case before. Okay, so if you think about, I don't know, what do students get discounts on? So maybe cinema tickets. Maybe if it wasn't for student discounts on cinema tickets, you just wouldn't go to the cinema. Okay, so maybe we're in this world, but by allowing price discrimination, we move to a world where students get a different price to everyone else, and welfare's improved because now students get to go to the cinema when they couldn't before. Let me just see if there were any other exercises. So that was really stupid. That was very easy, that one. So I also had some on slide 16 about two-part tariffs. This might be useful. So again, there are two types of consumers, and again we have Q1 is 1 minus P, and Q2 is A minus P. So that's the same. So this is slide 16, linear example of second degree discrimination with two-part tariffs. So it's a very similar exercise, but rather than setting different prices in the two markets, you're selling to them by choosing a two-part tariff. So you're saying if you want to buy Q units, you have to pay an amount T of Q, which is F plus PQ. Okay, so you have to pay something to walk in the shop, and then you pay something for each additional unit you pay. Okay, so if this firm is selling in both markets, just as before, it sells a total quantity of 1 plus A minus 2P. Okay, it's very similar. So its profits are going to be the revenue it gets from this tariff. Okay, so how do they do it? So imagine that there's a mass 1 of this type of consumers and a mass 1 of this type of consumers, okay? So these guys, well, they're going to pay the fixed cost, okay? So profits are going to be 2F, and they're going to get charged some price P, and they'll demand some quantity. What quantity? So the price P, they'll demand the quantity 1 minus P. Okay, so 2F has the fixed cost from these guys, fixed tariff from these guys, and we also have the revenue from selling the good to those people. So again, we just have price times quantity. Okay, so price is that, quantity is A minus P. Round demand of that price. So this is what profits would be equal to with this tariff. Marginal cost is, let's take marginal cost equal to 0 to make our life easier. So the firm has two choices, okay? It chooses F and it chooses the price. So it chooses the cost to enter, kind of walk into the door of this shop, and the price you pay once you're in the shop. So profits are just increasing in F. Okay, so the firm wants to set F to be as high as possible. Okay, and the highest possible value for F it can set is one where consumer surplus is as low as possible. Okay, so we started by saying that both types, we're assuming for the moment that both types want to buy the good. Okay, so for both types to want to buy the good, both types must be getting some consumer surplus. So if you do a kind of standard diagram, there's one, okay, maybe A is here, here's A. They're paying some price P. Okay, so for the low types, their consumer surplus is this area. For the high types, the consumer surplus is a big triangle. Clearly, the high types are getting more consumer surplus than the low types. Okay, so if someone's going to be, if F is as high as possible, these low types must be just indifferent between buying and not buying. Okay, so F must be chosen such that F is equal to the area of this triangle. And what's the area of that triangle? So that's A, that's P.
Half, excuse me, half A minus P times Q at half.
So this is 45 degrees.
It's 45 degrees, so it would be the same.
Yeah.
So squared.
So that was the first exercise I set on that slide. Draw a diagram to show that the thermal wants F equal to that. So once we know what F is, we can plug that back in. Okay, so pi was that, and that's equal to A minus P all squared plus P 1 minus P plus P A minus P. So there are lots of p squared here, so it's probably a good idea to multiply out these brackets. Okay, so this is a squared minus 2ap plus p squared plus p minus p squared plus ap minus p squared. So we've got 2 minus p squared, 1 plus p squared, so that's going to be 1 minus p squared. So we've got a squared. We've got a plus AP there, we've got minus 2AP there. So we're just going to have minus AP. We've got a P there. Plus P, and then P squared, I said we have minus P squared. So that's what their profits are. All they've got to do now is choose for price. Okay, so it's a straightforward problem to maximize that at a maximum. The derivative will be equal to 0. So the first order condition is going to be minus A plus 1 minus 2p. So taking 2p over to the other side, p is going to be equal to 1 minus A over 2. Is that what I had on the slide? Yeah. So minus A over 2. So with these two-part tariffs are interesting because it's not just in the price discrimination example. they weren't extracting all of the consumer surplus from anyone. Okay, even when they could price discriminate. Here, because they have this non-linear tariff, they can do better than a monopolist would even. They can extract all of the consumer surplus from one type at least. Okay, so if they choose to sell to both, we found the F vel set and we found the P vel set. Okay, so you can substitute that back in and you can find total profits. And the final exercise I say, does the firm always want to sell in both markets? And I give you two particular cases to compare. So what you do for the final part is exactly what we did for that first exercise you saw. Okay, so this is profits from selling in both markets. They also have the option of just selling to these guys, work out the optimal F and P in that case. So if they're just selling to these guys, what will F be?
It will be 1 minus P squared over 2.
Yeah, exactly. So if they're only selling to the high types, they can charge a higher F. Okay, so when they sell to both types, the high types are still making some consumer surplus. Okay, so the consumer surplus of the high types is the big triangle, and we've taken out the little triangle. So the high types are making some consumer surplus originally. But if you don't care about the low types, then you can charge people even more to come through the door. Okay, and you can remove any consumer surplus from the high types. And there's a trade-off there between the value of extracting this extra bit of consumer surplus versus the value of the extra demand. Leave that for you to go through. Should we have a look at the things from the next lecture? So did I set you any exercises during? There was a really tedious one on slide 24, which I won't go through. Yeah, it's just algebraic manipulation, that stuff, isn't it? Okay, so here's a slightly more interesting one. So slide 27, practical considerations. I say shops may have their prices set centrally, and the exercises verify that if firms take prices as fixed, they will choose to locate in the centre. So that's a useful exercise, I think. So it's a hoteling model. Did you all go to the lecture last week? Not many people. Okay, so we've got the standard hoteling line. Consumers are uniformly distributed between 0 and 1. There are two firms, we'll call them 1 and 2. No, we'll call them A and B even. And firm 1 is going to be located at point A. Firm A is going to be located at point A. Firm B is going to be located at point B. And A has some fixed price PA. B has some fixed price PB. Okay, so we're assuming that firms can't choose what prices to set. So, imagine a supermarket where all the prices are set in London. This is a supermarket in Manchester. Okay, the supermarket in Manchester doesn't have any discretion about what prices to set. So we're going to solve for their optimal locations. Okay, so the first thing, we need the profits of these firms. Okay, to get the profits we need demand. To get demand we need to find where the indifferent consumer is. Okay, so you always start solving these models by finding where the indifferent consumer is. So let's assume linear transport costs. So the effective price is going to be P plus TD. Okay, So to buy from a firm that's charging P, but it's the distance D away, you're going to pay P plus TD. So T is your cost per unit of walking. So would someone like to shout out the equation for the location of the indifferent consumer here? So there's going to be some point X, okay, where the person at that consumer at that point X is just indifferent between buying from firm A and paying PA and buying from firm B and paying PB. Okay, well, if he buys from firm A, what's he going to pay? Well, so he buys the good for a price PA. What's the distance going to be? So he's at X.
X minus A.
Yeah, exactly. And if he buys from firm B, well, he's going to pay a price PB, and the distance he's walking is B minus X. We can solve this to find the value of X. Okay, we've got Tx here, we've got minus Tx here. So let's take all of the Tx's over to this side and everything else over to the other side. Okay, so 2Tx is going to be Pb plus Tb minus Pa plus Ta. Okay, so I've taken Tx to that side and everything else has just gone to the other side. So if I divide everywhere by 2t, you get x is 1 over 2t times Pb plus Pb minus Pa plus T times B minus A. Okay, so does that make sense? If the price of firm B is high, then the indifferent consumer moves right. Okay, so if the price of firm B is very high, the indifferent consumer moves right, which means more people are buying from firm A. So that seems plausible. And if the two firms, okay, so this last term we've got T B minus A divided by 2T, so that's just B minus A divided by 2. Okay, so if the two firms are selling the same price, the indifferent consumer is going to be halfway between A and B. It should be the average, shouldn't it? Well, there's a minus sign wrong somewhere, isn't there? TB plus TA, sorry, so that should be okay. A plus B. So it's always worth checking the intuition of these things because it's a good way. It's a good way of seeing where you've made a typo. So we know where the indifferent consumer is. Okay, so once you know where the indifferent consumer is, it's easy to work out profits. Okay, so all of these people are going to buy from firm A, all of these people are going to buy from firm B. Okay, so the demand going to firm A is just X, the demand going to firm B is 1 minus X. So firm A's profits, let's assume 0 marginal cost, but firm A's profits are going to be X times PA. Okay, so pi A will be X times PA. And pi B will be equal to X times PB. 1 minus X times PB. 1 minus X. So let's do it for firm A to start with. Okay, so if we just expand that expression, we have pi A is PA over 2T all times PB minus PA plus T times A plus B. So pi A was x times PA, so all we've done is just written that down. So if you know the value of pi A, normally we'd start by solving for PA and PB. Okay, firm A would be choosing PA here, but we're taking PA as fixed for the sake of argument. Okay, so we're just gonna maximize this expression with respect to A. So we're going to choose A to maximize their profits. And it's pretty easy to see this is just increasing in A. Okay, A only appears in one place, it's just increasing in A. So the optimal thing for them to do is going to be to set A as high as possible. And if we're constraining them to always be on the left of the other firm, because nothing makes sense if they're on the other side, they're going to set A equal to B. Okay, so the optimal choice of A will be whatever B is. So this was for linear transport costs. So in fact, the optimal choice of A is B, and you get the same thing for the other firm. You get the optimal choice of B being A. So in fact, for lots of equilibria with linear transport costs, so as long as they're both from the same place, they don't really mind where that same place is. If you do it for quadratic transport costs, you'll get them locating exactly in the middle, I think. So let's kind of redo the exercise with quadratic transport costs. So now their cost of buying from a firm that's charging a price P and is distance D away is going to be P plus TD squared. So the further you walk, the more tired you get, maybe. So we're going to get something that's exactly the same, but we just have some squared terms in now. And when you multiply out these brackets, you get, on the left-hand side, there's a tx squared. It's a plus tx squared. On the right-hand side, minus x times minus x is still x squared. So there's a plus tx squared on the right-hand side as well. Okay, so the x squared terms are going to cancel out. And what you're left with, let me just write out the brackets for you. So PA plus tx squared minus 2tax plus a squared is equal to pb plus tb squared minus 2tbx plus tx squared. Okay, so the tx squared terms are going to cancel out. So what you're left with is the terms in x. We've got a 2tax there. There we've got a 2tbx there. And they both have minus signs. Okay, so when we take it across to the other side, we're going to get 2tx times b minus a. So if we take that to the far side, and then on the other side, well, we've got pb plus tb squared, and we've got these terms from here, so we've got minus pa minus ta squared. You follow? Just multiplying out some brackets, hopefully this is right. So then we want x is what we're interested in, we're a different consumer. So we divide everywhere by 2tb minus a. Okay, so you get x is PB minus PA plus TB squared minus A squared all over 2TB minus A. Okay, so again, if B's price is high, X is moving to the right. Okay, so more people buy from firm A. So that makes sense. And if PB is equal to PA, then X is going to be at B squared minus A squared over B minus A over 2B minus A. So, you know, if B was equal to 1 and A was equal to 0, say, then this would be 1 minus naught over 2 times 1 minus naught, so a half. So it seems plausible. Just double check. Yeah, that's what I had before. So that's where the indifferent consumer is with these quadratic transport costs. And then, again, just as before, we use this to find out what the profits of firm A were. Okay, so pi A is this thing times PA. And if you do this thing times PA, well, you get a PA in the front. Okay, so let me just write P pi A is equal to PA times all of this. Okay, and this firm is taking the price set by A as fixed. It's taking all prices as fixed, and it's just choosing where to locate. So it's choosing A squared. So all we have to do is maximize this expression with respect to A. And as A gets closer to B, you know, so if A was equal to B, this thing would be as big as it could be. And we just have to check that that's right with the thing on the bottom. Okay, so the first order condition, okay, is going to be, so let's use this rule. The derivative of u over v is u dash v minus v dash u over v squared. So here the derivative with respect to A, well, we have derivative of the top, which is going to be minus 2AT. Oh, and there's a PA in the front, so it's going to be minus 2 PA AT. U dash V, okay, the thing on the bottom, which is 2TB minus A. So this 2 times 2 is equal to 4. T is going to become T squared, B minus A. U dash V minus V dash U, okay, so the derivative of the bottom is just minus 2T. Minus 2T times everything that was on the top. It's a bit messy, isn't it? PA. All over the V squared. Okay, so 4T squared B minus A squared. So you get this expression for the first firm, okay, you'll get something symmetric for the second firm. Let's make our life a little bit easier by assuming that PA is equal to PB. Okay, so Sainsbury's head office is telling them to set the same price as Tesco's head office. Okay, so that'll make things slightly easier to start with. But PB doesn't appear. No, that's supposed to be a thing. Doesn't help a lot, does it? So PB is equal to PA. This term drops out. So now this is a t squared. So all the t squares are going to drop out of this equation. And in fact, this can be simplified quite a bit. And in fact the PA's are going to drop out, okay? So naught is equal to this. We can ignore this bottom bit, okay? The thing on the top must be equal to naught. And we can divide by PA. Those are going to drop out. So in that case we've got naught, I really hope this works, naught is equal to minus 4. The t squareds are all going to drop out, okay? So minus 4a times b minus a minus 2 t squareds have dropped out, 2 pa's dropped out, b squared minus a squared. Okay, so if b is equal to a, this thing is 0. So if they choose a as b, then this is 0, this is 0. So again in this case, they want to choose a as b. It's a bit of a pain, isn't it? Okay, so linear case was easier. It's probably the end. Did you have a go at any of the exercises in Oz Shy? So I said exercise 7, 6, 2, 3, 4.
Not this week.
Not this week.
We've been overrun with tests at the moment.
Yeah, I know. It's easier to know what to do in these classes if people have a go and tell me what they can't do. So 2 looks straightforward. It's just a hoteling model. So 3 looks worth doing. We don't have time to do it now, but you should have a go at exercise 3 because it seems like an interesting variation, which might be helpful later on. So 7.6 exercise 3 is certainly worth doing. And 4 is very similar to what we just done. Okay, so I'll see you tomorrow.
Tom, quick question.
Yeah.
Is the mock for last year's end of term test worthwhile doing, or should I just wait? Should we just wait?
Is that online?
Yeah,
It is
on your thing.
It could be. I'm not sure. I haven't decided what I was going to ask you. So last year I asked a long exercise.
Tesco Sainsbury's.
Yeah, and it confused a lot of people. I think it was quite a good exercise to ask because people thought it was one type of question. Actually, it was a different type of question. I was slightly tempted to just describe some situation, not a model, and ask you to build a model of the situation and solve that model. So maybe there wouldn't be just one model that you could write down. Obviously you'd see the situation in advance, so that's another possibility.
Okay.
Would that be fun?
Is this the final exam or
The end of term test. I don't know. What would you like for the end of term test to be? Does that sound like an interesting end of term test?
Well, the obvious answer is easy, but
Well, you want it to be satisfying, don't you? You know, you're doing some quite tricky stuff in this course, and people are doing okay. So if Isn't there some satisfaction in doing hard stuff and still?
There's satisfaction doing it sort of outside of the timed exam, but when it comes to an exam, you kind of like, right, I want to maximise marks here.
Yeah.
So satisfaction kind of goes out the window. I mean, I don't mind working through stuff that's sort of quite difficult when you've got no time limit. It's just kind of when you're in an exam room and your eyes on the clock and something goes slightly wrong.
Huh?
So you found the time hard in the last one?
I struggled, but
Yeah.
I think my writing speed slowed up because I didn't have to write anything for ages.
You know, but I don't know. It's part of it being an exam. It's
Oh,
like
yeah.
you don't have enough time.
Official feel pressure.
Yeah. Yeah. Okay. Okay. Well, I'll think about it.
Cool.
See you tomorrow.
Cheers, Tom.